Thanks everyone for joining. My name is Mike Lenz, Director of Marketing here at FlexXray. Really excited to be joined by everyone on the line, as well as our two great panelists for this morning's presentation, or if you're Giancarlo, this afternoon's presentation. He's located in Italy. And we have a really exciting topic today. There's a ton of interest in this presentation. And there's no surprise because CT technology and its applications in the food space are really leading edge, and we're really excited to announce just this past week that FlexXray is building out new capabilities as part of a partnership with BIOMETiC, which is one of the most innovative detection equipment providers in the industry. And so today, very happy to introduce our two panelists that are going to bring some really great perspective to this discussion. First off, we have FlexXray's own Chief Product Officer, Kai Luker. Kai is the true brains behind our operation here at FlexXray. He's been responsible for developing the process we use today to inspect product and deliver the most accurate inspection results to you as a producer. Kai is also responsible for evaluating new technology that's going to help us generate even more accurate results for your biggest foreign material challenges. We're also lucky to be joined by Giancarlo Zane, Head of Sales and Engineering for BIOMETiC. Giancarlo leads the growth of BIOMETiC in the food industry and has helped bring advanced inspection solutions to producers worldwide, always with a strong focus on innovation and customer needs. So some really great experts that we're going to have on the line here today to explain this new application of CT technology. Before we kick off, just wanted to do some brief housekeeping. Throughout the presentation, if you'd like to submit questions, you can do so in the comments box to the right. If you're watching here on StreamYard, or if you're streaming on LinkedIn, there should be a comment section just below the feed. So feel free to submit things as we go. And we're going to be answering them at the end of the presentation. So with that said, I wanted to start things off by showing a video to you all provided by BIOMETiC that helps explain the machine we're talking about today, which is BIOMETIC's Mito CT technology. So we're going to have Giancarlo kind of walk us through what we're looking at as we look at the Mito machine in action. What, Giancarlo?
So what you are seeing is how our inspection system Mito uses 360 degrees CT scanning to inspect the food products in real time. As product moves through the machine on our conveyor belt, they are scanned by rotating X-ray source, which create a detailed 3D image and their external and internal structure. We will show some real-world scanning examples shortly. This level of detail allows Mito to detect even small contaminants or quality issues with high precision in real time. What makes this especially effective is that Mito achieves this full 360-degree coverage with just one source and one sensor. If a contaminant or quality defect is detected, then the individual product is automatically removed without stopping production. The same technology is already used in line by our customer, and now it is also available for batch inspection in US thanks to our partnership with the FlexXray.
All right, so that's a great overview, I think, of what we're looking at with the Mito machine. Help us understand a little bit from a technology perspective what CT helps us see better versus traditional X-ray when it comes to foreign material.
So the main difference between a traditional X-ray system and a CT scanner lies in how the image is reconstructed. CT reconstructs the scanned product in 3D in real time, providing a point-to-point density information. Traditional system instead provide only a flat 2D projection, essentially an average density from a single point of view. This makes a big difference when there is a very little density contrast between the contaminant and the product, like when you are trying to detect a rubber gasket, for example, or when the product has a complex structure, which can hide foreign bodies. Another key benefit of the 3D reconstruction is that detection is orientation independent. If a metal wire, for example, is aligned parallel with the X-ray beam, It's often invisible to the 2D systems, but CT still catch it. In fact, while some competitors try to reduce blind spot by adding multiple sources and sensor, Mito uses a single rotation source and sensor to achieve full 360-degree coverage, resulting in lower maintenance cost and easier integration. This full 360 degrees scan eliminates blind spot and guarantees consistent detection through the products. So even in difficult scenarios like finding glass fragment in glass containers, it can detect them even in the bottom or under the cup, where traditional systems usually fail. And beyond safety, this enhanced visibility also helps verifying the product's structural integrity, giving producer great confidence in what reaches their consumers.
All right. Well, thanks for breaking that down, Giancarlo. I think next up, we've heard about kind of what the technology does, but what's the output in terms of an image scan? So we're going to have Kai now break down the next video, which helps us see what Mito is looking at as we break down an individual product.
So this is a rendering of the screen itself that the operator sees at the machine. And some details from the software itself. So we're scaling back individual layers of the glass jar in question here until we actually can locate the defect. That glass in question here is adjacent to the glass jar itself, and due to the Mito's ability to recreate that rendering from any angle during the actual X-ray inspection, we're able to find that, where in a traditional 2D X-ray, the location of that piece of glass adjacent to the container itself would make it difficult to virtually impossible to detect.
All right, thanks, Kai. So I guess just taking a quick step back, Giancarlo, help us understand a little bit about the history of BIOMETiC and kind of why you all have decided to develop CT for the food industry.
Yeah, BIOMETiC is part of a Microtech group that is a company which over 45 years of experience in industrial scanning in food industry. Microtech is the first and only company in the world to implement industrial tomography to scan logs and optimize cutting. From this experience, we saw a gap in the food industry where effective foreign body inspection was still missing. That's how Mito was born, the only CT scanner adapted specifically for food inspection. And thanks to its unique 3D reconstruction capability, Mito can detect smaller and more type of contaminants with higher accuracy and fewer false positives. Let me share a recent example. One of our customers was facing a contamination issue with irregular particles that were undetectable with traditional systems, even those using multiple X-ray sources. By using Mito, they were able to identify the contaminants early and avoid discarding the entire batch. In total, over 1,500 pallets of product were saved, which would have been rejected if only traditional X-ray systems were used. This is a clear example of how Mito helps reduce waste, save cost, and ensure only safe, verified products reach the market. We see great potential in North America, where producers are seeking smarter inspection methods to enhance food safety, minimize recalls, and safeguard their brands. And this is exactly why our partnership with FlexXray is so important. It brings Mito's technology in the US as a batch inspection service, giving producer access to advanced CT inspection without the need for inline installation, making it ideal solution for batch inspection needs.
All right, thanks, Giancarlo, for the background. So Kai, next question's for you. So FlexXray, we know, already has some of the most powerful X-ray technology in its facilities. It's helping us get more accurate readings generally than a typical inline machine. Why did you decide to kind of look at CT as the next wave of technology to invest in?
Yeah, thanks, Mike. For those of you not familiar with FlexXray and our services here, we're using a medical grade imaging system in order to inspect food for foreign objects that are difficult or impossible to find at production speeds and help manufacturers recover from incidents. Right now, that's all a human-based inspection, and although we're using the same imaging devices in a heart cath lab to produce the best X-ray image possible, we're using 16-bit detectors in our inline systems right now. Those systems are not automated, and we're seeking an opportunity to improve our journey from analog to digital and now into automation.
Okay. And as far as the challenges it helps, overcome compared to traditional X-ray, can you break that down a little bit?
Yeah, Giancarlo talked a little bit about it right now, but the number one thing, it allows us to inspect foreign material and product combinations that we would have said no to over the last 20 years. In fact, over the course of this year alone, we've inspected with the machine that we've installed May of 2024, we've inspected over 30 truckloads and 15 unique project combinations that we would have said no to in the past.
Do you have an example of one of those that we can kind of break down?
Yeah, in fact, Giancarlo and his team are helping us with an update on their algorithm right now. We're looking for glass inside of a nut container. It has a fiberboard cylinder, but metal top and bottom. So a lot of interference with the metal from the container itself that prevents a good inspection process. But with Giancarlo's team, we're able to ignore that part of the packaging material, focus on the glass itself. And in traditional 2D X-ray, we may have said yes to this project at a size of 5 to 6 millimeters in size, but we're down to 3 millimeters and below in glass detection for this project.
Okay. And I guess, I want to try to tackle some of these questions as they come in, because obviously this is spurring a big discussion over in the comments. So first question, I think that ties into what you're speaking to right now is, how does this work with plastics? What are the capabilities compared to traditional X-ray?
That's the number one benefit that we've seen so far with the Mito scanner is the effect of the product interference within a 2D X-ray alone. It basically masks the location of that plastic, making it very difficult to achieve detection. And due to the reconstruction with the Mito, we were able to peel back the layers down to a 0.5 millimeter slice and locate that foreign object in any position within the product zone.
Okay, great. So we've got a handful of other questions that are sort of product specific. I think we'll come back to those a little bit later in the presentation. We're going to show some examples and kind of what the output looks like from the CT system. And then we can jump into any specific questions you all have, but keep the questions coming. This is great discussion so far. Okay, so we've kind of broken down the capabilities at a high level. I think a lot of people here are starting to wonder, some of the more technical specifications. So Giancarlo, if you could kind of talk a bit more about the technical specs of the Mito machine, specifically things like its aperture, and then I see a question around run rate as well, but, let's see what we can cover here.
Yeah, we currently offer 3 different models, Mito B for bulk products, Mito C for scanned goods, and Mito M for multi-packs. All have a 250 millimeter field of view. Recently, we developed the Mito M with a 500 millimeter field of view, designed to inspect larger and taller packages. And FlexXray is the first company in the US that used this model for batch inspection. For a technical perspective, Mito is designed for 45 7x7 operation. It features a magnetically driven rotating entry with no friction and very low wear, scanning speed up to 40 meters per minute, and more than 400 images per second. It uses just one X-ray source and one sensor, which reduces maintenance and complexity compared to a 2D systems with multiple sources and detectors. And for customers who want to use Mito inline, we offer custom configuration supported by our internal mechanical design team. to ensure smooth integration into existing lines.
Awesome, thank you. I guess, Kai, is there any difference there, in an offline capacity as far as run rate or any considerations there?
Versus FlexXray's current technology, we're running around 4 to 5 feet per minute, and currently we're running the MITO at 20 feet per minute. There are some recipes that we can bump up to 30 feet per minute, but we're trying to help our customers recover from incidents that occurred during manufacturing. So at the slower rate, we're able to achieve higher success in ensuring that we're locating those defects.
All right, great. So, I think we've talked a bit about, the MITO machine and CT generally from an accuracy perspective. Any notes you want to share as far as inspection operations and how it's helping us get more efficient there?
In automation alone, right now we're inspecting everything manually. We do a lot of stop-start because of that, where we're having to shut down the X-ray, open the cabinet, retrieve that product from the X-ray zone, remove that, to be able to achieve a continuous inspection. Even though compared to manufacturing speeds in the US, 20 feet per minute may sound slow, it's a significant improvement in performance for us.
Awesome. All right. Well, I think that's a great overview of, the capabilities of the MITO machine. I think what folks would probably love to see is some of the examples of what this has looked like when we're applying it to an actual food production setting. So with that said, we're going to kick off with some examples here. Kai and Giancarlo are going to break down what we're seeing. And then again, keep the questions coming. There's some great stuff here. We're going to bookmark some time at the end where we can go through all these. If we need to stick on a little bit longer, we can certainly do that to make sure everyone's questions get answered. So the first one up here is a image of peanut butter. And Kai, if you want to start us off.
Actually, I'm going to let Giancarlo speak to this one. These are all examples that we're about to review of things that FlexXray has provided to BIOMETiC over the course of the last couple of years as we've developed this partnership. We've tried to test BIOMETiC with a lot of things that were extremely difficult or virtually impossible for us to inspect. And every single time, Giancarlo and his team has knocked it out of the park with their ability to locate foreign material. So I'll allow him to speak to exactly what's going on here with the peanut butter example.
In this peanut butter jar, as you can see, we place the contaminant at the base, where a traditional 2D X-ray system usually fail to detect foreign materials because it's one of the most tricky place in the jar. But thanks to the MITO's point-by-point density reconstruction, as shown in the image at the bottom of the screen, the contaminant appear clearly visible, and that's absolutely not how you will see in a traditional 2D system.
Yeah, Mike, while you've got that image up there, the upper left picture, it looks like a traditional top-down view in a 2D system. Yeah. But what we would look at that picture normally is we're looking through all the interference of the entire product layers. With this top-down view, we're only looking at that singular layer where the contaminant is located at.
All right, thanks. The next thing we're going to take a look at is a fried pasta bundle.
Yeah, this is an interesting case for us from a FlexXray perspective. And it's difficult without a 2D X-ray here to look at and compare to all of the layers of the product and the textures and the overlap and even the voids within the product. Make a visual inspection with 2D technology virtually impossible because operators having to discern that foreign object that looks fairly easy to locate when you peel it back to a single 0.5 millimeter layer. But when you're looking through all the layers at one time, extremely difficult. So another successful test here by BIOMETiC.
Yeah, as Kai said, As Kai said, I think the interesting part of this example is the complexity of the structure of the product. The ravioli overlap each other. There are voids in the filling, and when you have an average density, and especially from a single point of view, as in traditional system do, it's almost impossible to detect any foreign materials, especially when there is a low difference between the density of the foreign body and the product, like if you are looking for rubber or plastic. That's almost impossible in the 2D system, but here is clearly visible. Like you can see the small sphere that we have on the lower part of the picture. That is the contaminant that we put it inside.
All right, thank you. So one final example here, and this I think is one of our most notoriously challenging projects to do, but we're able to do it with the CT system. So Kai, this is a protein jar powder.
Yeah, absolutely. It's one of my favorite projects because we see these a lot from a FlexXray perspective, and we don't get to say yes to these projects very often. You know, finding a piece of a broken or missing scoop, it already has such similar density to not only the product, but the container and the scoop itself in there. And if it doesn't present itself in the perfect orientation, it's just virtually impossible to detect in 2D. But once again, as we can peel back those individual layers and we can do point-to-point evaluation for a foreign object, we can see the location of a broken piece of scoop within a jar that also contains a scoop. And in fact, in some of these tests, we placed the broken piece of the scoop inside the scoop to even try to challenge it further. And the BIOMETiC machine, the Mito, had no issues.
Yes, the challenge here, as Kai said, is the presence of the presence of the spoon, that it's placed inside the product, but can be in any position of the product. So the information that we obtain from the 3D construction can give us the possibility to distinguish the spoon from the foreign material, not only for a difference in density, but for the shape of the spoon. And so the Mito is able first to identify the spoon and his position, and then analyze the rest of the power to detect any other contaminants.
All right, thanks. So that's the three examples we're going to go through today. As I said, we've got a bunch of questions that have been submitted, and we're going to kind of work our way through here. We're going to start off actually with one that was submitted by email prior to the event. So this is a question for Giancarlo. So you've talked about Mito being used in FlexXray's offline use case. How long have you had a machine in a production environment for?
Mito is already running production environments across Europe, installed in line of companies such as dairy, jam, bakery, ice cream manufacturers, providing its versatility and reliability with a wide range of products and packing formats. Mito was officially launched in 2019, and our first installation in the food industry was with Latteria Vipiteno, that is a well-known dairy cooperative in Italy, where Mito inspects glass jar of yogurt directly on the production line. Today, Mito is a mature, proven solution trusted by some of the most quality-focused producers in Europe. The maturity of the solution means that producer choosing to work with FlexXray benefit from a technology that is already proven in demanding real-world environments.
All right, thanks, Giancarlo. I see a couple questions here on plastic specifically, so I'm going to have Kai tackle these. So, currently traditional X-ray is limited in terms of detecting certain types of plastics. What are the capabilities of detecting plastic material? I know you covered this a bit, but if you could summarize that and kind of, what the capabilities are, what we can see versus what's still typically not able to be detected.
Yeah, there are still some difficult items, don't get me wrong, bag liners and glove tips and things like that are still extremely difficult. A CT scanner doesn't make something that's completely invisible to an X-ray visible, but traditional gasket, O-ring material, we've seen belting, curtains, things like that are a thicker plastic that are impossible to find in a 2D X-ray, the Mito has been successful in finding those things. So the better quality plastics that you're using in your food manufacturing environment, the higher the detectability is going to be with the Mito.
Okay, thanks. Giancarlo, this is a question about hygiene with the Mito machine. So has the unit been designed with hygiene in mind, specifically around food contact surfaces and cleanability?
So the Mito has been designed all in stainless steel to be used in a food industry. It's not still an hygienic product. So because it has been designed for packaged product mainly. So in the future, probably we will develop a hygienic version for not packaged products.
Gotcha. Okay.
Just to say that a different way for our US customers here, Mike. So all packaged product in any configuration, the Mito is a good candidate for inspection for, and it can be washed down in your production environment. It's things like raw product, raw package handling in the US that it's not ready for yet.
Mm-hmm. Okay. Yeah. Amanda here had a question. What about incoming raw materials, specifically thinking of meat products, whether that's meat meals, frozen blocks, or fresh meat? Either you want to tackle that.
Would need to be in its original packaging still, just to make sure that we maintain sanitary conditions.
Okay. So we've got a handful of specific product questions. I'm just going to fire these off at you, Kai. So one is around its use for pet food. Another is its use in dry pasta.
Dry pasta is absolutely fantastic use case. In fact, our factory acceptance testing that we do with the new machines that we're commercializing are based off pasta inspection. It's been one of the things that we've been able to find that's difficult to inspect, a lot of edges, a lot of product density. We're using a very large package size whenever we do this in order to put the machine through its paces. Absolutely. Sorry, Mike, what was the other product?
The other one was pet food.
Absolutely. So pet food mimics, human food for the most part, especially with the advent of a lot of refrigerated and frozen products and canned goods. With kibble, even though that's a very dense, dry product, the Mito has shown a high degree of success with everything that we've thrown at it.
Okay. And the last one here that I think relates to that, but probably you just answered, is how does CT technology work with loose bits versus homogeneous material? For example, kibble pet products or cereal products, which have been harder to find contaminants with traditional X-ray.
Yeah, that's where the machine really shines. The difficulty with 2D X-ray is as soon as you increase the diversity of the product or inclusions or things like that within the product zone, the performance of 2D X-ray is deteriorated. But with the Mito, because we're basically rendering that from any angle and can go to any point within that scan to locate foreign material, we overcome all of those obstacles.
Okay. Appreciate that. So a couple more questions here. Giancarlo, is the system focused on food production versus a facility receiving the products, for example, a prison or a hospital?
So the Mito have been designed for especially for food industry and in general for industrial environment. The tomograph used in medical environment have different, for example, different requirement, like the speed. For example, the Mito is able to scan up to 40 meters per minute. Instead of medical, CT has a much lower speed, and Mito has been designed to work 24/7. So the characteristics of Mito is especially designed for industrial environment and focused on food industry, especially.
Great.
Mike, just to say that a different way, the Mito is designed for a food manufacturing environment, and Giancarlo and his team are able to develop, recipes and algorithms and to set that up for exactly the form, material, and product combinations that you're seeking. I think the question lends itself more towards institutions, prisons, hospitals, where you see a diversity of products. And that's where FlexXray can come in and support those types of inspections, where we're able to see and handle a wide array of diverse products, get those back into commerce.
Mm-hmm.
Great, thanks. So just a couple more here. So first one I think is for Giancarlo. So how does this technology differ from the Mito B 3D technology?
The Mito B with
yes.
So Mito B is made for bulk product. Is more washable system, and at the moment we are using this kind of system for inspect, for example, unpitted olives, to see if there is any olives with pit inside in unpitted products. Or, for example, we are using that in chestnut to detect any rotten chestnut in this kind of product. So is a bulk product, is made for bulk product, and is washable with water inside.
Okay, thank you. All right,
Mike, we've been focused on foreign material. I would hate to not talk about some of the other things that Giancarlo was just mentioning. The Mito machine is fantastic for finding things that are missing or improperly filled or located within the product zone as well. It's just as effective as an analytical tool within your manufacturing environment as it is a detection tool.
Gotcha. All right, so last question I think we have time for here. So Kai, where is the CT machine going to be located within FlexXray's network?
The first two pieces of equipment will be installed here at our Texas location. The second two this summer will be installed at our Illinois location, and will continue to expand across the network throughout the year.
Awesome. All right. Well, thank you to both Kai and Giancarlo for giving us an amazing breakdown of this exciting new technology, and to everyone who joined, who was submitting questions and part of the discussion over here on the right-hand side in the comments. We really appreciate you guys continuing to show up for these, to ask great questions, to engage with our panelists. And so we're going to keep coming with a few more webinars throughout the year where we're able to tackle topics like this. So again, thank you for your time. Thank you for joining us. And we're excited to see what applications we have for CT for your products. All right. Thanks, everyone. Have a good rest of the day.